Hi, in this tutorial I'm going to show you how we can use WebAudio-controls together with WebAudio-XML to build a simple synthesizer. So we have this example called Simple Sint. And we find a keyboard here, and that is generated using WebAudio-controls, and you find the link below the video so you can implement it yourself. It's very easy. As soon as this script is implemented in your web page, you can have some custom HTML elements, and in this case I use the WebAudio keyboard element. There is one called WebAudio knob and one called WebAudio slider and WebAudio button as well. That is super useful to quickly make a keyboard, and that actually can provide MIDI in as well in an easy way. So you find more information on their web page. Anyway, I set up this keyboard with 25 keys starting from MIDI note 48, and it's 660 pixels wide and 250 pixels high. So that's why it looks like this and works like that. The interesting thing is how we connect it to WebAudio.xml, and this is what this tutorial focuses on. And we have two new elements here. One called Sint, and that is the container for everything that is needed for the synthesizer. That could potentially be like a multi-sampled polyphonic sample player instrument, or that could be like an FM synthesizer, or like this, a subtractive, more like analog-y synthesizer. The structure is like this. So the synth is the container, and it reacts to incoming events. So what this does is actually in the background adding a JavaScript layer using the add event listener targeted to the WebAudio keyboard element. It listens for the change event, and it uses the note property of the event passed to the event event listener function. And if we read the specification for WebAudio-controls, we see that note property, is a list, an array of two values. It's the MIDI note number, or maybe it's first one or a zero for if it's a down or a up event, and then it's the MIDI note number. So that will be used to control how the synth react to incoming signals. Inside the synth there should be at least one voice element. So this voice element is a container working a little bit like a mixer element. So it actually mixes whatever elements are inside the voice element. You could have actually multiple voice elements, which makes it possible to have like different blueprints for a voice. And if we then set this attribute voices to more than one, we could potentially have like every second note playing with a square wave and every second with a sawtooth, or with different, any kind of settings. Could even be like an FM synth for one voice and a sawtooth analog-y sort of cut-off frequency filter sound on the other note playing at the same time from the same MIDI keyboard. But we can also set voices to a higher number than one and have just one voice, and then the voice is copied to make it play polyphonically. Anyway, inside the voice we can have elements, and in this case we have one chain inside the voice, which means that this chain is the only child element in the voice, and the output of the chain will be connected to the voice, which is then passed to the Sint, which is then connected to the main audio element, which is then connected to my ears again. So what's in the chain? Well, it's very similar to what we've seen in earlier tutorials. It's one oscillator node, one gain node, and one bicode filter node. Actually, I realized that I haven't used a Q value before, and it might be good to comment on that one as well. It's a bit confusing with case sensitivity when it comes to XML. I think it's rock solid when it's external files, but then when we have embedded XML data, as we do here at CodePen, in some browsers it gets a bit confused. So attributes or even node names might be sort of uppercase just automatically, even I mean, if we've done like camel case as I've done here. So actually what I type here is like the suggestion. That's how it's meant to be. But I think most of the settings will be case insensitive anyway, because it has to be to work in different, for both external files and embedded XML data. So we have a Q factor. You can read more about that on WebAudio API documentation. What else is new? That's probably it. So we've learned about envelopes and how we can use envelopes inside a parameter. In this case, the gain parameters. We have an envelope controlling the amplification of the sound, causing the sound to ramp up to its maximum volume and then sort of falling down to 50% of 1, which is the sort of maximum volume. And then after we release the key, we have a 200 millisecond release before it's quiet. The signal also runs through a bicode filter node, and because I don't set the type, it will default to low pass. The frequency is a parameter of the bicode filter node and can have its own envelope. So this is how it could look, controlling the frequency with ADSR, attack, decay, sustain, release. So we have a ramp up 200 milliseconds until we reach the peak of the filter, and then falling down, taking 200 milliseconds to reach 20% of the maximum value. And then after releasing the key, we will have a 100 millisecond release until the filter is closed. And this is now a bit different compared to when we control the gain level with envelopes, because frequency is a parameter that can potentially be like 20,000 hertz. We need to specify the maximum value for the envelope to match that range. So I set up this envelope to hit the maximum point at 3000 hertz, which means that this will then be 20% of 3000, causing the sustain level to be 600 hertz in this case. So that's where you kind of control the amount of the envelope. You could potentially put the envelope inside a detune parameter as well, which would then have like the frequency possibly to be set to a fixed value, and then having the detune control with the envelope, and that could then cause the sort of basic level of the filter to be set to like a fixed value, and then the envelope kind of controls that above, sort of adds to it. It can be interesting also to see how we control the pitch. So oscillator has a frequency, and frequency follows, and now it's quite simple, because when we were using the mouse before in earlier tutorials, we had to map incoming values to outgoing MIDI values to make that kind of make sense. But now when we have a MIDI controller as the input, we can just say follow MIDI. And if we want, we can have like a second value added to it. So we can have like number 7. Then the sound will be a fifth, perfect fifth above whatever note we play here. So, and if I take it away, oh, we need to wait. Okay. So that is how we build a synthesizer. And of course we can do anything like with mixers, having 2 oscillators playing different, one playing the MIDI note I'm playing, one playing in a perfect fifth above or whatever. And we can mix the oscillators together, run them through filters, and we can have FM synthesis with separate oscillators controlling each other and all sorts of things that you learned in the other tutorials. But this is how you connect a web audio control keyboard to WebAudio XML structure.